In this lesson, we'll begin building the curves that will become our lane markings for the roads. This setup will need a few different curve types. First, we need what I call cyclical lines. These are loops that follow both the outer shoulder of the road and the inner shoulder along the inner curves. They'll run around the edges neatly. Next, we also need center lines that sit between the lanes. These will change based on how many lanes we have. Also, sorry for the rough sketch here, but we'll want to place some lines down the center of the crosswalks or the crossroads. So we need different parts to build this system. We already have inner and outer curves from our road setup. And earlier, we separated the road mesh into two curve types, one for the boundary curve and the other for the interior cross edges. We'll use these now too. First, let's duplicate the mesh to curve node. This will convert the inverted selection into a curve as well. Add a reroute to move this over. Let's group it with Ctrl+G to keep things clean. Inside the group, rename the inputs and outputs. We're outputting a mesh, and for the input, instead of just curve, name it curve cross, because it will be our crossroads curve. Now rename the group itself to lane markings. Adding a period keeps this node from showing in the Add menu, which we don't need. Duplicate the input for the crossroads curve 2 more times to create 3 total. 1 for the cross curve, 1 for the inside, and 1 for the outside. We'll also need to bring in all 4 of our road setting values. Add new inputs for each one. First, make an integer input and name it a number of lanes. Then add float inputs for a line width, a shoulder width, and a sidewalk width. Now go back out of the group. Add a group input node and connect it to each of these settings. Then connect the curve inputs from the road setup. The outside curve goes to the outside, and the inverted selection goes to the inside. Add some reroutes to tidy up the wires. Now we have the lane markings node group ready, and we can add it to the join geometry node. This will make the cross curves show up in our geometry output. Let's now focus on the cyclical curves. Start by disconnecting the output for now. We'll use the inner curve first and apply an offset to it. Use the Offset Curve utility group. Connect the inside curve to it. How much should we offset? Think of it this way. If there are 2 lanes, then we'll have a center line, and the lines go to the side from there. We'll base this offset on the shoulder width. That will give us the correct position for the inside shoulder line. We'll repeat the same for the outside curve. Hold Shift-Control and duplicate the offset node while keeping the same links. Now connect the outside curve. Join these two together using a join geometry node. This gives us both the inside and outside shoulders. However, you'll see that the outside curve is offset in the wrong direction. To fix this, simply reverse the offset. Now both shoulder lines are positioned correctly. Just like before, we need to round the corners using a fillet curve node. Set the count to 12 and use the sidewalk width multiplied by 2 for the radius. This keeps the corners consistent with the rest of the road. Use Ctrl+H to collapse the node options and organize the layout. At this point, the shoulder line curves are complete. Next, we'll build the rest of the lane lines that go between them. To place the center lane markings, we'll duplicate the outside curve and offset it multiple times. Luckily, there's a helpful node for this. Duplicate elements. This node lets you copy splines, points, or faces a certain number of times. Drop it onto the outside curve. One thing to know: that the amount input doesn't mean how many times to duplicate, but how many total items you want. If you view it, you'll see it shows only one spline at first. This may seem odd, because you might expect 2 splines if it duplicated once. But it just means that the result will have a total of that many items, depending on the domain. You can also use a selection input to control what gets duplicated, though we won't need it now. Delete the viewer node. How many center lines do we need? Well, we've already placed the outer shoulder, so that's 1. Then a center line between lanes, which makes 2. And the inner shoulder is handled separately. So the number of copies is the same as the number of lanes. Duplicate the group input node and connect the number of lanes to the amount input on duplicate elements. Collapse the extra node options with Ctrl+H to keep things neat. Now we want to offset each duplicated curve. Use the offset curve node again. It's good to adjust the default value on the offset inside the node group if it keeps resetting to 10. Remove that default. Now we'll set the proper offset distance. First, reverse the direction so that offset values are positive. For the offset value, we'll use the line width, because each lane is spaced that far apart. But here's the key. We don't want every duplicate to be offset by the same amount. Instead, use the duplicate index, output from the duplicate elements node. This gives the index of each duplicated item. Multiply that index by the line width to space them evenly. Since the index starts at 0, the first one stays in place 0, 3, 0. The second moves by 3, the third by 6, and so on. This method creates evenly spaced center lines based on the number of lanes and their width. Plug the multiplied result into the offset input. Now we have all our cyclical curves laid out as needed. In the next lesson, we'll use these curves to create markings across the cross edges.